All right, back to our lecture on digital audio. So, how does this process of A to D and D to A conversion work? Analog to digital, digital to analog work. Well, if we're working in digital, that means we're working with computers. And computers are not smart enough, they're not able, they're not designed to make continuous recordings of just about anything, let alone of sounds or a sound wave. Analog recorders could do this. When you're recording on analog audio tape, it was continuously moving tape and it would continuously be recording what was happening. Computers are not capable of doing that. It's impossible for them to record every little tiny plot on this waveform mathematically. So, how do they do it? What's their secret? Well, computers are very good at rapidly, and I mean rapidly, we're talking, capable of 100 plus times per second or more, taking very rapid pictures, or samples is a better way to think of it, of what the sound wave looks like at a particular moment to a particular moment. So if our wave is moving like this, it goes along here and around here, the computer is really good at taking picture, 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 even more so as it's going along. So it may not be able to have that full wave, but it can plot out those points. And I think you might see where we're going with this. Analog to digital converters work by repeatedly measuring just the amplitude, which, as we know from before, is the volume of an incoming electrical pressure sound wave or electric voltage. What does that mean? We'll get to that in a second. And then it outputs these measurements as a long list of binary bytes. Again, if you're not familiar with computers, you may not know what binary bytes means. We'll actually get a lot more into that in the next lecture. But with these binary bytes, these little bits of information, it creates a mathematical picture of the shape of the wave that it's trying to create. All right? I think you saw that in the last picture. You take sample, 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 sample. It's like connecting the dots. An easier way to think of this is that the computer is creating a long connect the dots, like I just said, of what the sound wave looks like when it's being recorded. Each time a waveform is measured, a binary number or digit is generated that represents the voltage of the waveform at the exact instant it was measured. This process is called quantization. You might want to remember what this term is. Quantization is an important term. Each time a waveform is measured, a binary number or digit is generated that represents the voltage of the waveform at the instant it is measured. This process is called quantization. The process of quantization has improved, but pretty much hasn't changed since the 1980s. The process maps a large set of input values, also called samples, to a smaller set and then rounds the values to some unit of precision. This comes in a concept what's called bit depth, which we'll get to in the next lecture. The computer takes a set of number Computer takes a set number of samples per second. So that's important as well, which we'll get into when we start talking about frequency. How do digital computers record frequency is based off of the number of samples per second they take, but we'll get to that in a few more lectures. The number of samples gives us the possible frequency range we can record. As I said, we'll talk about that more in a little while, or a few more lectures. The accuracy of every one of those samples is determined by their bit depth. And we're going to go into this a lot more in the next lecture about what bit depth actually means. But for now, just think about bit depth is all about resolution. How good are our measurements? But before we move into that in the next lecture, really want to take a look at how this computer is taking these samples. How does a computer take a sample? What is it sampling? How does it work? What exactly is it measuring? We know it's measuring amplitude, but how is it measuring amplitude or volume from a computer? How's a computer measuring volume when it can't necessarily hear the way we hear? Well, it comes down to what we talked about in a few lectures ago on how a microphone sends its signal. You have that diaphragm with the magnet and the wires, and it vibrates around, and just like in a power station, it creates a current, and it sends that electrical current down the wire. Well, computers are very good at measuring electrical current. So every sample the computer measures is a measurement of the voltage level that the microphone is producing at that moment. So whatever the amplitude is of that sound wave is going along, here's amplitude level, you know, every point around here on this plot of a sound wave, these are all varying amounts of amplitude. And so those are all varying amounts of voltage that the microphone is generating at that exact moment. And so the computer is measuring the voltage at that moment. The voltage level represents the amplitude. So the stronger the voltage, the stronger the amplitude. The weaker the voltage, the weaker the amplitude. And the level represents the amplitude of the audio signal at that particular moment in time. So as you look on here, each one of these measurements is measuring the voltage at that particular moment in time. And this arrow on this plot here is representing how intense that voltage happens to be at that moment. And it plots all these points, which creates our idea of what the sound wave looks like by connecting the dots afterwards. But again, remember, the computer is doing this all incredibly rapidly. You put all the samples together on a chart, and you can easily see the shape of the sound wave. Just like connecting the dots when you were a kid. Now, we're going to end here, but the accuracy of each of these measurements is based on bit depth. And we're going to talk about bit depth in the next lecture. But how good your audio sounds will be largely based upon how good each of those measurements actually is at each of those individual moments in time, and how well is the computer actually able to take those measurements. But again, we'll get into that in the next lecture. Thank you.